Hello class, in this video I'll be using the fundamental theorem of calculus to evaluate a definite integral, and then I will interpret the meaning behind that value. So let's begin. So I want to find a value for the definite integral from -4 to 2 of x squared plus 2x minus 1. And the first thing we need to do is ask ourselves, is this function continuous? And the answer to that question is going to be yes. And that's because f of x is a polynomial, and all polynomials are continuous on the domain of all real numbers. Okay, so now that we established that f of x is continuous, we can apply the fundamental theorem of calculus to evaluate the definite integral. And we've already established that this function right here is lowercase f of x. So the antiderivative is going to be capital F of x. Okay, so to find the value of this definite integral, I want to evaluate capital F at 2 and evaluate capital F when x is equal to -4. So let's do that. So capital F is equal to 14/3 when x is equal to 2. Capital F is equal to -4/3 when x is equal to -4. So f of 2 minus f of -4 is going to be 14/3 minus -4/3, which is equal to 6. So the value of this definite integral is equal to 6. And what does that 6 represent? Well, if I come over here to the graph, this is the graph of f of x is equal to x squared plus 2x minus 1. And when the graph is above the x-axis, that represents positive areas, so I'm going to highlight it in green. And when the function is below the x-axis, that represents negative area. So I'm going to shade that in red. So the area in red plus the area in green is equal to 6. And that's what the value of this definite integral represents.